demo that we have for you this afternoon. My name is Cale Harbor with Advanced Control Solutions, and together with our sister companies, Olympus Controls and Gibson Engineering, we make up the Applied Automation Group. And with us today, we've got an exciting new realm of technology. We've got Olis Robotics with us to talk about how you can operate industrial robots remotely to be able to help out with applications and troubleshooting them to add yet another level of capability to keep your manufacturing environment up and running by that remote connection to it. And with us today, we've got Ned. And Ned, you and I were talking right before the event, and I kind of relayed years ago, maybe 15 years ago, I ran into an application where a robotic welder was being used by a company for a nuclear power plant. And they had to operate everything remotely to do the welds. And it took up 2 overseas shipping containers racked with powerful computers and servers and like 12 people to monitor it. And it was this very complex thing. And I think we've come a long way over the last 15 years, and that you're going to let us know a little bit about this after.
Absolutely, absolutely. Yeah, thanks very much for that introduction. Very happy to be joining all of you this afternoon or evening or wherever you are, whatever time zone you're in. I've been selected to help demonstrate a product that is really hard to demonstrate. There are a couple things about this that just make it kind of challenging. So it's fun. We figured out some ways to be able to show this. We're kind of showing 2 things. We're showing what the product does, but we're also showing a new way to think about industrial robot programming. This isn't changing the way you program robots, but this is adding a new piece of teleoperation as a programmatic step. So I think you may get, may find that interesting. I'm going to share some high-level overview on Olis Robotics, the company, and on the product, and then I'm going to spend most of my time trying to demo live on this UR5 that's behind me. I'll go ahead and share my screen. So as is my particular desire, I'm going to spend less time on slides and fluffy overview stuff and more time looking at the technology. But I do want to share some of the high-level overview stuff with you about Olis Robotics. It's about a 10-person company in Seattle, and their focus right now is to move from a world where really they're a global leader in teleoperated robots for undersea applications. Most of the customer base was really in the area of undersea applications. I might even kind of jump forward a couple of slides here. These subsea applications where you're working undersea on drilling wells or telecommunication cables. Obviously, you have to be in a teleoperation mode. You can't get people down there. So they had a lot of success in this particular area and worked with me. I'm kind of like voice of the customer joining you today. I've used their product in a couple of different areas. And we said, is there a place that we can use this teleoperation capability in industrial robotics? Briefly introduce the team. Don Pickering is their CEO. He's on the call. We've had some interesting challenges in getting this presentation put together. Don is trapped in an Airbnb with no Wi-Fi. Our CTO, Frederick Ryden, is in Norway with his wife and their brand new baby, making the rounds of family. So we've had some challenges, being able to coordinate for this particular date and time. Explains a little bit about why I'm joining you today. And Steve White and Howard Chizek kind of round out the team. Okay. Couple of background pieces, and then we'll get into the product. Why would I want teleoperation in an industrial robot? I'm an industrial robot programmer guy. I've been putting robots and vision systems into factories since '84. This is what I do. I have been in this industry for a very, very long time in a lot of different venues. Teleoperation is typically not a thing that we think about in writing an industrial robot program. Industrial robot program is supposed to be autonomous. It just runs until something goes wrong, and then somebody runs over there and fixes it, and then we keep on going. Okay, that's the scenario that we're typically in. What we know is that there are kind of obstacles to getting all the way to lights out, right? At the very, very end, there's this kind of last mile, it all works except every 3 hours, there's a part that gets kicked out. And if I can write my program in such a way that I work around that, hooray, you get a gold star. But if something comes along that was unexpected and that I haven't already, coded in, I've got a more difficult problem, So this is sort of the kind of mindset, that we're that gave it gave birth to this product idea, and what Olis is doing is taking these ideas of manipulation and autonomy, right, and also the whole IoT revolution, and saying, okay, is there a way that we can help out someone who's writing UR programs, and then other robots, which will be coming online behind that? Is there a way that we can do that and make it valuable? Okay, almost done with slides, I promise. We've got, this is sort of the high-level architectural picture of what I'm going to be demoing to you. So in order to do teleoperation, you need something with which to teleoperate. So it could be a joystick. Most of the people in the audience are significantly younger than am I, and so they actually know what to do with these particular kinds of devices, right? These are very inexpensive, ubiquitous, easy to find, and so this is the standard interface. Those offshore drilling guys like very big, heavy things because they're kind of rocking and rolling around. And there actually is a whole other kind of mechanical interface to the product, which is also, optionally used with this. In order to be able to teleoperate a robot, you need two things. You need to have control of the information stream. I need to be able to command it where to go and continuously see where it is. I need a simulator that draws up a picture for me of what the robot looks like, so I can kind of imagine where it is. And then I need, one or more, several live video streams, so that as I'm moving this robot around far, far away from me, I've got some idea of what the heck I'm doing, So the way that works is next to your robot goes a small IPC. You'll probably recognize the color. This is a very popular brand, IPC. Happens to align with Olis's logo colors, so that's a happy coincidence. Probably save them about $4 in the long run when these go into mass production. You put this IPC next to the robot, and what the IPC does is it coalesces those control and telemetry streams with video streams, squirts all the stuff out through a private VPN, and they've done a great job with the software so that things find themselves automatically. There are ways to do this through AWS, through Google Cloud. Azure has technology for this, and a bunch of other startup companies. Ixon, for those of you who have used those routers, that I'm kind of excited about these days. Anyway, establishing that network connection, especially from a factory floor, can be challenging. So this thing kind of automatically does that. Okay. What I want you to take away from the demo, what teleoperation does, it's going to let me operate the robot remotely. So that handles fault and recovery kind of operations. It also can be plugged in, and this is my big letters on this slide. It allows teleoperation to be thought of as a program step, which is specifically what I'm going to demo to you. So instead of just thinking about, I'm going to remote into the robot and move stuff around and then I'm going to restart it, this is way more powerful for me. This is, I wrote my robot program, the robot program is running, everything's fine, except at this one moment I went to grip the part, and instead of winding up with a 12mm part, I have a 9mm part, and I'm not really sure what to do. Can I send somebody a text message and tell them, hey, it's time to teleoperate the robot? Get in here, take a look, you fix this, and hit the start button and get back to work. So that really is the idea that I think might be unfamiliar to most of us. It certainly was an unfamiliar idea to me as a decades old robot programmer. So that's the thing that really is sort of interesting. Last slide, and then we're gonna go ahead and demo. This is really what I'm going to be showing you, is teleoperation as a UR step. Now, I mentioned we first released this on the UR robot. We're working on interfaces with Yaskawa. We're working on interfaces with Epson. we're interested in working on interfaces with everybody. You know, the software has specifically been written to work with many different kinds of robots. It actually already does work with a lot of non-industrial kinds of robots, academic sorts of robots. So it's a, you know, it's a standard process for Olis to customize for other robots. But what you're going to see if you're familiar with polyscope programming is somewhere in my polyscope program, all of a sudden I've got an Olis teleoperation step that has been inserted in there. And when that happens, all of a sudden it's going to be my turn to finish the job, you know, and then let the program keep running. So that's what I want to demo to you. Great. Now on my screen, and this is where I alluded to the fact that, holy cow, this is a hard product to demo. You know, I've been demoing robot and machine vision stuff, you know, the better part of my entire life, and this one is still a hard one to demo. So, you know, this isn't a perfect demo setup by any means, but I think you'll get the idea. Okay, I think you get the idea. The window that I have right here on the screen. This window is a copy. I'm remoted in to the Olis Connect laptop. Okay, so this is the laptop that you would have off in the middle of nowhere. You know, you're the remote robot technician. You've got this laptop, and this is the software that's running on it, and this is what you would see. Okay, this is also the laptop into which your game pad is plugged. You know, this is your remote teleoperation station. Could be anywhere in the world, as long as it has an internet connection. What I've and what you'll see on this is I've got a picture of the state of the robot, and I've got a couple of video feeds coming in. One is a Bosler camera. The other one is actually the integrated camera that's built right into the laptop. System's capable with any compatible with any camera that currently any camera that follows the Genie Cam standard. So you can have several cameras and you get an array of video feeds. Okay, I've augmented these video feeds with a couple of humongous Axis security camera video feeds, which really just helps you, you know, see a little bit more what exactly is going on here. You know, what am I doing? And then what I've also done is I've VNC'd into the polyscope. This is the UR robot controller, you know, so that we can do some things on that as well, and you can see what that's all about. Okay, great. Let's go ahead and write a program. Okay, this is here we go. All right, I'm going to put the robot in local control, and I'm going to assert that I would like to write a new program. Why not? What could possibly go wrong? So we're going to write a very simple program. I'm going to start with a move command. I'm very happy where I am right now, so we'll start by saying that we want to move to where I currently am. Then I'm going to go ahead and I'm going to add another move command. We'll make that a linear move. And I'll say that there I want to move somewhere else. I guess we can kind of jog over, you know, this way, or maybe we'll go this way, keep ourselves. You know, I always like to be close to crashing into things. It makes robot programs so much more interesting and fun, right? Aren't we glad it's a UR and not a FANUC? I probably wouldn't be as confident having this thing whack around behind my my back. Well, now, not if it was a FANUC cobot. Okay, that's a different story. Anyway, we move to waypoint 2, and then just because I like programs that loop, we're going to go ahead and at the end of the program go back to waypoint 1, and now I've got a super exciting program that basically we're going to have to move back to robot 1 for those of you who know how the URs like that. And so now we've got this program running that moves from waypoint 1 to 2 to 1, and it's doing this over and over again because, as most of you know, by default, UR robot programs loop forever. So I'm going to just change that, and we'll go ahead and we'll, you know, run this program one time. So it starts here. Make sure I'm all the way back in position 1. We run the program. It moves out and it moves back, right? We do this again. Same thing, okay? Last part of the demo. We're right on track here. So obviously I could go ahead and, you know, I could be, you know, activating my gripper. I could be checking things. I could be checking digital IO. You know, I could be finding something, touching off on it, opening my gripper, grabbing it, then checking 2 digital IOs to make sure that I really had it grasped the right way. And then I find that one of those digital IOs is off, and you know, this is kind of the scenario that I want you to think about. So what I do is, I'm not going to bother putting a conditional one in here. We'll make an unconditional one and you'll get the idea. Under UR caps now, because I have installed the Olis Teleop UR cap, you know, which you can see if you're familiar with UR caps and things. The Olis Teleop system is installed. The only thing it needs to be configured for is the IP address of the Olis Connect computer that it's connected to. This is the local, that orange computer that's next to the robot. So that's the only IP address it needs to connect, and then everything is just kind of up and running. Okay. Once I've installed that Olis UR cap, you know, which you'll see in my list of all of Ned's favorite UR caps, at least, you know, for this week. Once that's installed, then back over in my program, exit, you know, remember that button. Back over in my program, I've got a Olis Teleop function. And if I put an Olis Teleop function in here, there are a whole bunch of ways that you can get this to terminate. We're going to leave this as the standard way, which basically says once teleoperation starts, it's going to stay in that mode forever until the person who is teleoperating says, I'm done. Okay. We could put timeouts in here. We could say you only get to teleoperate for 1 minute and then I'm going to take back over. You know, there are all kinds of different interesting things to do. And just for fun, we will modify this message that we're putting up here. We'll say, you know, teleop demo, say something like that. Okay. So now I'm going to save this program because I'm that kind of guy. Give it a really, test one. I've never used that file name before. And then we put ourselves in remote control mode so that I can now remote control this whole robot from this location. Okay, that's kind of the idea. You'll see that test1.urp is the program that I have loaded. I could change what program is loaded directly from the Olis Connect interface, which is super handy. Okay, since that program is loaded, I'm going to go ahead and run it. So what should we expect to happen? So step one is the robot moved out to waypoint number 2. Now we're in Olis Teleop mode. It says, hey, you got control of the manipulator, okay? And now I've got control of the manipulator. I can come in here, I can move things around, I can swing, I can control my gripper, I can rotate, I can do all kinds of fun stuff, right? All of these things, you know, are now possible. I'm teleoperating. I can adjust the speed of my robot. I can adjust the speed that the gripper fingers are opening and closing. I can choose to operate using kind of a jog button interface. So what you'll see here is my simulation of the robot is moving along with my actual image of the robot, right? I can, you know, so I can click along here. I literally did teleoperation of the robot on my phone one evening. Didn't have this interface, but I certainly could teleoperate the robot using these nice little jog buttons. Okay, so we go ahead and do that. We can also operate either in world coordinates, really robot-based coordinates, or tool coordinates, TCP coordinates. Okay, so we can kind of play around with all that stuff. And then when we're done, when the teleoperation is done and I've fixed whatever problem it is that I'm supposed to fix, go back to gamepad here. Once I've, you know, done all of that, then I go ahead and I say, okay, I'm done with teleoperation. When I'm done with teleoperation, then the program finishes running and we're done. Okay. So what I ask you to think about there, you know, and this is one of the things that I love about this particular interface, you know, the Polyscope ecosystem, you know, this world. Once I show you this, I say, hey, you can drop this thing into your program anywhere you want, at any time. When you do that, if this interface is already open, that means I'm sitting here and I'm watching it. It will just immediately pop up on the screen. If this interface is not open, you can go ahead and put an alert phone number in here So if nobody is watching and the robot decides it's time for teleoperation, somebody gets a text message. That's kind of how that works. Now, this is Rev 1 of this product. We have a huge and very interesting technology roadmap ahead to add on all kinds of additional features to it. But even at this level, this kind of version 1.0 kind of level, I certainly felt that it was the kind of thing that that should be brought out into the world. Let people take a look at this. I think it can address, solve, an awful lot of problems. It doesn't answer the problem of machine learning and real autonomy. It doesn't answer the problem of perception systems that are visually aware and can identify every object that they ever see. These are all really interesting problems, that I've spent a lot of time working on in a more academic sort of context. But meanwhile, out here in the real world, we're trying to make robots do real stuff. And if we don't have the ability for the robot to figure out what's going on, isn't it cool that we can bring in a little bit of additional intelligence, to try to save the day, or get us back up and running. Obviously, in very large enterprises that maybe have a team of super robot programming wizards, on site 24 hours a day, as I had at some of my former employers, this has a kind of a different focus. This might allow you to fix things faster, right? But for small and medium enterprises where you may not have that 24/7 dedicated force, or if you have 3 machines go down at the same time and you've only got 1 person, which of course never happens, right? If you have a situation like that, this I think is a really great tool that can really help get over some of these early obstacles. I think I'll call it quits at that point so that we leave plenty of time for any questions or feedback or thoughts that anybody has. And really appreciate the opportunity to show you not just really the product, but the idea. The idea of embedding this in a typical robot, industrial robotic program, and then all of us thinking about, okay, what can I do with that? Because this is a very general capability.
Yeah. Thank you, Ned. We had a couple things that have come in from the room so far. One of them has to do with security. Obviously, if someone's going to remote in, they have to have access to the network to some level. How do you
Yep.
handle keeping the network secure for that remote login?
Yep, that's a terrific question. Obviously, in each different scenario, you may get a different answer. If it was me with 2 CNC machines in my garage, I might not even ask that question, right? It's like, hey, I want to go away with my wife for the weekend, and while I'm out of town, I want to be able to, jog the robots around.
Right.
On the other hand, if I'm in the middle of a data center somewhere, and there are a bunch of other security concerns, this can be a much bigger problem. So there's several different solutions that we've used. There are off-the-shelf solutions for creating VPNs on AWS, on Google Cloud, on Microsoft Azure. There are also standalone products, places, people like Zero Tier, kind of standalone products. I also mentioned Ixon. This is a very interesting product. I've got it in my own lab. This is a router that can connect either hardwire or Wi-Fi or cell to the internet, and it also can connect all 3 given a certain priority. And it has the ability to connect securely outside of through the public network, creating a virtual private network tunnel. So our approach on that has been to not dictate. There are certain companies that will only accept one solution, and then the next company says we'll accept anything except that solution, and then the next company says, oh, we built our own solution. So we've tried to decouple the product from the selection of VPN. If customer doesn't care, our off-the-shelf solution is Nebula through AWS, and you just plug everything in and it just works. And it's private. You get your own VPN addresses, So
Okay.
that's evolving, and we expect that certain customers will have certain requirements, but that's a networking problem that won't require changes in our product.
Okay. No, the other question that we had that came in from a machine builder standpoint, ship machine out with 5 robots on it, rather than having to send a technician out every time something needs to be remote troubleshot, they could see the value in something like this to be able to possibly save that airline ticket on an emergency basis. Would they need one of your IPCs per robot or one for the cell, and then it could connect to the 5 robots of that cell?
Yeah, that's a great question. In principle, the software is architected in such a way that it could work with multiple robots. The limiting factor is the bandwidth of the IPC. So what I would be worried about is less the traffic from the 5 robots, but the traffic from how many cameras. How many cameras need to be in each one of those work cells? Because
Okay.
quite frankly, the biggest challenge, if you're going to be operating the robot remotely, you need good multiple video feeds that don't have huge amounts of latency. And so that really is the thing that would be the limiting factor there. Our CTO is in Norway and he's away, so I can promise all kinds of things, that he would be unaware of, but certainly one trade-off would be to go to a higher power IPC to be able to serve more video feeds, but from a software perspective, there aren't really any limitations.
Okay, that's it. That's all we have in the room for today for questions. Ned, I do want to thank you for your time with us and for participating. And for the audience who's here, we have recorded this. It is going to be placed on our YouTube channel. Be sure to check it out if you'd like to review the demonstration or share it with one of your coworkers. Also, take the time to look at the online trade show. Go to the booth for Olis Robotics to learn a little bit more about the company. You can request a meeting with them, or you can email either us or the folks at Olympus or Gibson, and we'd be happy to set up a time to meet with you and talk in more detail about your applications. Ned, thank you again for spending the time with us. It's an innovative product, and I wish everyone to have a great afternoon.
Thank you. Same here. Thank you, everybody. Very much enjoyed it.